There we go. Hello, everyone. Welcome to another virtual meetup. We're so excited to have you. Today we have a great presentation with Michael Cizmr from MC+A. But before we dive into that, the usual, we'll go through what to expect, a few resources. So real quick on the Elastic DevRel side, my name is Olivia Petrie. I'm a program manager, and I'm also joined by Justin.
Hey everybody, Justin Kesty here, Senior Developer Advocate at Elastic.
So real quick, we'll cover how to get involved, a few resources, and then jump right into the presentation. At the end, we'll have plenty of time for questions. So if you think of any questions throughout Michael's presentation, please post those in the chat and we'll cover those at the end. So real quick, how to get involved, a few resources. So if you have any questions related to Elastic, troubleshooting, anything like that, highly recommend checking out our Discuss forum. I'll post the links for all of these in the chat here shortly. Additionally, Elastic Slack Community Workspace is a great resource for questions, announcements, all of that. And then our Elastic Community YouTube channel, which is where this video will live. We post all of our virtual meetups as well as solution-focused content as well. If you're interested in presenting at a meetup in the future, we have both in-person and virtual. We'd love to hear from you. Reach out to us at meetups@elastic.co. And then finally, join your local Elastic user group. We have close to 150 user groups globally. We'd love to have you at an in-person event. So I will post this link. Again, you don't have to scan the QR code. I'll post all of this here shortly, and you can see what user group is closest to you. So with that, I will turn it over to Michael. Let me add you to the stage and your presentation. Hey, Michael.
Hey, welcome everyone. Thanks, Olivia. Thanks, Justin. A little bit of background of myself. I've been working on search since about 2003. Started working with AI solutions incorporated in search around 2016. I've done hundreds of search implementations and generally virtually every use case. And that's pretty important when you talk about search because there's so many variables that are really determinant on what you're trying to achieve with that. I posted recently a ingest plugin out there for open source, and everything that I'm presenting today, just about everything will be is up on GitHub as well. So I thought we'd start with a quick primer on RAG and kind of title this "Why Should You Care?" Like what's unique about it or what you need to consider in building a effective solution. And in the implementations that I've done and the company's done, I think some differences in terms of what you might be reading out there versus what is being done. And I'm just noticing, are my slides not moving forward?
I think you have to go onto the screen and click next slide or previous slide.
Okay.
How about
Yeah,
that?
okay, I see what Roger that. You've got this. Okay, I'm also sharing it. Perfect. Got it. We will. Or I think we're good. Perfect. So, why is RAG a thing? So we've got these LLMs out there from DeepSeek, Llama, and all these. They have context windows. Google's go up to 1 billion. Why do we need to focus on retrieval augmented generation? So first and foremost, generally your knowledge, your corporation's knowledge does not exist in the LLM. Thankfully, right? That's a big concern for everyone. So you have to provide it that knowledge in context. Typically, knowledge within organizations has particular permissions, and in the even though you have a large context windows, the features that are available within the context windows change over the distance or the size of the context window. So even though you have 1 million, what it can do with that first chunk and then the larger chunk are going to be different. And then most importantly, you want to feed specific data, and I'll use this word, in context. So that's key. Context is king. Uh, so you know what you're trying to do and or achieve in a particular workflow, and if you can provide just what's necessary to the LLM, you're going to find that you get the best results. And so for these reasons, RAG is a thing. Now you'll typically see some sort of this is from Elastic Lab, showing more or less what a typical stack is. So a user provides a query, that query gets embedded, that embedding is run against a Elastic's vector database, and passages are returned. You feed those passages through your prompt and back into the result. So what I'm here to kind of say is that you don't need a vector database in all cases. It is again, it's to the use case. You don't necessarily need a chunk. And I'll show you some examples of how you can do RAG without a vector database, how you can do RAG without chunking. But those are pieces and methods to a particular problem. I mean, the most widely used use cases is sort of Q&A. So where you're asking a specific question, that question is embedded in a passage. That passage answers the question, and the prompt will summarize it and provide that. We're working on cases where the corpus is, say, 90 million documents. And so it's not really effective to have chunks, or you just can't use an out of the box strategy to do that. And I've kind of showed this in the make vectors great again. But the big thing here is that tokens are not all equal. So as you take text or a image and you turn it into a vector, it is that knowledge is not all the same. And so you're typically putting filters onto it, and they're for a date range, they're for a specific area, and also for permission. So if you're not entitled to see some of the content, then that's essentially a filter that is applied. So and again, reiterating, not all your knowledge is going to fit in a single passage. I look at these when we build knowledge graphs. A lot of times they look like this because there's just so much redundancy. There's so many topics, and our goal, and what sort of the title of the or one of the bullet points in the description was this inverted pyramid. So our goal in RAG is to narrow down the haystack so that the LLM that's ultimately going to be processing that is more effective. So you start with your knowledge, you're putting filters on it for context, and then you are narrowing it out so that you have as razor sharp content. An example of, if you want to use recency. Recency is a huge factor in something that you may look for. So if you're trying to get an answer on ChatGPT, and it's related to a library that you're familiar with, you want the most recent one. You don't want the most you don't want something from the past. And so you want to filter out that sort of knowledge so that you're getting the context that's most recent. And that is the inverted pyramid. So when we talk about a local AI stack, I'm definitely saying A. There's a few of these that you can run for it, but this is one that we find to be very easy to set up, gets the job done, and that is to use Olama along with Docker, this LM orchestration tool, Dify, and then the Elastic Stack for the vector database or for your knowledge repository. Olama, if you're not familiar with it, here's the link. Some links. It'll download and install on Mac OS, Windows, and Linux. Key here is to not run it with Docker, particularly on Mac, because Docker virtualization on Mac does not expose the GPU. So you'll be running only in CPU mode, and while that works, it's slower. But if you don't have a GPU, then it won't matter. But Olama will also work. The models are tuned for CPU use. Elastic, why Elastic? Because you could do lexical, you could do vectors, sparse vectors, hybrid re-ranking, serverless, it runs local, SQL. So, like I said, you're not always having to run a KNN search or a hybrid search. You could be running just, pull up orders from the last 30 days and provide me a summary of what occurred on that. That's a structured query. There's not much interpretation there, but you can get started with the Elastic Stack by just simply running this command. I've also included in the GitHub a Docker Compose that I typically use because it also adds the enterprise node to the stack so that you can do a web crawler and use any connectors. Dify, with Dify, you're going to be able to create workflows, AI endpoints. You're going to be one thing that we spend a lot of time doing is creating and tuning prompts. If you've heard of prompt engineering, it's the new thing, but it is a thing. You can also develop agents. You can test. It'll host chats, chat flows, and then it builds in some monitoring. I'll show you that in a few moments. You can get it locally here. It runs in Docker. It's a pretty complicated Docker of 5 to 7 different containers. If you don't want to run it locally, there is a free edition that you know on Dify to run it. But as the title here is run local, we're going to go with that. So here you can get clone, CD into the CD Docker, make a copy of the environment variables, and then simply Docker Compose up. And then voila, it looks something like this. So it comes with a lot of out-of-the-box examples that you can use. And so we'll kind of now switch over to some demos, particularly in workflows and agents. First one I've got for you is chat with a PDF. So this is a pretty popular one. And what you get when you start Dify is a workflow WYSIWYG editor. You drag and drop various components together, and then it assembles them into an API endpoint or a chat. So here we're starting with a product sheet, which is a file. So, and then we're going to extract the file into text. We're going to pass it through. This is Llama 3.2 running locally with a prompt that I have. Your sales assistant. Here's the context of it. And I said retrieval augmented generation, and then here's the answer. And so if I come here, I can do a preview. I've got here. This is a Snapdragon Elite product sheet, and let's ask it about.
Hey, Michael, just 1 second. I hate to interrupt you, but I'm not sure if you're able to share your screen for what you're showing.
There you go.
Okay, cool.
All right. I'm an idiot. Appreciate that. So let me just backtrack real quick. So I opened up a workflow in Dify. We have, as I mentioned, some monitoring available when you're running it. You have the ability to look at logs. It presents itself as an API endpoint. So if you ultimately want to take this out to use, you'll get that. And then I've created a very simple workflow that takes a PDF and answers questions about it. So the you wouldn't normally do this for everything because you're not going to want to necessarily, maybe it depends on the use case, but you're not going to want to extract the PDF every time. So in this, I've created a input field of a file or a document. You have a variety of choices here. And then it has a built-in extractor, so it'll extract it. We're going to go into the LLM prompt. It's going to use the context of that extraction to the prompt. And I've instructed it to just answer questions about the PDF and nothing else in its knowledge. And I can come over here and ask a question about it. So I'm just looking at the PDF. You can do something like, there we go. How many cores does the app? I didn't to reload it. Here it is again. There we go. Oh, that's not good. I think it took a little typo there. How many cores does the Snapdragon X Elite? There you go. So, and then I asked it to reference the section of the document. So that's sometimes pretty important when you are, in particular, testing out the LLM. Let's see if we can compare it to the Intel i9. Can you compare the Snapdragon X Elite to the Intel i9? You can kind of see it going through it. You know, and that's a sort of a chat with a PDF. So you're providing it the context without a vector database, without anything. And I mentioned that this may not be the ideal use case because if this is going to be a repeated flow, you'd want to potentially index that document into a vector database so that it's a little bit more performant doing that. These flows can be pretty extensive. This is one that'll just show that it has branching capabilities, it has looping capabilities. I've published, you can put code in here. So here's we're setting up the search request here, taking things from the embeddings, and then again calling out to Elastic in this case. So it's using Elastic and an API key to request that information and providing that then to the LLM in context. The Dify does have a knowledge capability, and so you can create and upload. Here's some PDFs of a app that we use, and And so you can attach this, but what we really like to do is to turn the knowledge into, we have this ability to use external knowledge. And so we can, with a very simple, we published actually today a wrapper for Dify to Elastic, so that you can use Elastic instead of Dify's knowledge repository. And why would you do that? You do that so that you have more control over how you chunk, how you create those individual documents. Maybe you're making parent-child documents. You want a particular model that you want to use. You want to store it. You're using it for something else. You want control over the retrieval query, which you don't really have that ability in Dify to do on its own. So when we use this, when we have a knowledge repository, and I'll just create something from blank here, create a chatbot. You can add the context here. So, and then this will be retrieved in your prompt, which is pretty cool. Another example. So agents are a thing, and what agents are described to be are these autonomous functions that will figure out on their own how to solve a problem. And so, well, we have that capability here, and I think in particular solving a problem, because a lot of the other tools I see out there are essentially sequential workflows, which don't really invoke the notion of autonomous. So what I've done in this is to create a agent that is supposed to look at a job rec, look at who applied, and try to match them. So we have our little, I shouldn't say our little, our prompt here, kind of describing what it should do. It then goes and references some key variables that are here, like fetch jobs. Down here we have fetch job, and use the index prospect finder. And then once I supply it with a job ID, it's going to go through and figure out how to solve the problem. Now it's running low. I've tried to do this everything with local, so it's going to run local. And while it's running local, I'll show the output of a previous run, because it does take a little bit of time. But here off it goes, and this is the run from before. And what you'll see is that it on its own decided to use the tools. So based on its analysis of solving the task, it said it needed to use fetch job, and then use get prospects, and I'll show these in a second. And then it did the analysis, and you can see here that this is about the job that we had posted in Santiago, Chile. So let's take a look at these jobs. So here's job fetch. We have job fetcher and index candidate fetcher. So if I come here, do a filter on this. And what's nice about Dify is if you make it comes with a bunch of tools, but you can make your own by simply creating a workflow. And then after the workflow is published, you can publish it as a tool. And so this is job fetcher. This is pulling, literally pulling a job from our job board. So again, you start with the job ID. You're setting up some variables here. So this is going to go to that API. It's using the API key. Here's the request out, and then it's transforming the result set to return. So here I created a workflow, and then the output will be available as a tool. And there's another one we made for this, which is the index candidates fetcher. So this is similar, but it's being provided an array of so the agent's asked to fetch the job, gather the IDs of the candidates who've applied, put them into an array, and call this tool. So it takes the array and makes it into a query that we can call Elastic. And then here's the Elastic call. It's really just doing a mfetch, mget, and then returning it. Again, cleaning it up a little before we send it back, and that's it. So I've made two tools initially, and then I've incorporated those into an agent to solve the problem. And then you'd work on the agent to put in your preferences to how you want it to score or give weight to the individual candidates, perhaps how you'd match that. You do something maybe more than just the IDs. As a Dify comes with a bunch of out of the box tools listed here, and there's every sort of release. There's more to it, so you can incorporate these tools within your agent or your workflows. A workflow is as simple as, I'll make a workflow now. I started from scratch. You get a blank canvas. You have all of these.
Michael, sorry. I'm not sure if we're seeing the screen for creating a. Okay, there we go.
Beautiful. Sorry, here. This is a fresh install. Fresh workflow. So you have all of these little tools. So we did the doc extractor before. If you want to call an LLM here, choose the LLM that you want. I've got some cloud ones, some local ones, and you sort of build it out that way. Just to kind of recap on that tool, in case that wasn't recorded, if we go into Studio, and I created these workflows and then published them as tools. So this is a sequence to this one, calls the API of our job board to get the job description and who's applied to it. Then it reformats it and returns it. And then when you finish it, you can publish it as a tool through this, and then it's available for agents to use. And then I did another one which calls Elastic, which is here. Yeah, and this is pretty simple, I think. And a more complicated example would be to use a more interesting query that you'd want to do to show or accentuate not just the candidate, but features of the candidate's posting. So once you have these tools, you publish them and then incorporate them into the agent, which is here. Just here. And if I wanted to add more, I could add any one of these that are in the library. And as I said, the prompt determines, will kind of teach the agent what to do. See if it finished. So it's still, this one's still going. I think lastly, I want to show the prompt capabilities. So I'm going to start a new chat, and we will just do this chat, and do a different one. see here. This will give a better demo, but so generating a prompt is sometimes easy to do, hard to perfect. I should say easy to start, hard to perfect. So you can come here and say, I want to extract entities from some text. Generate it, and there you go. Come back, paste it here. It's going to over, and now you can go through and generate that. So here's the task, read the input, and then you can sit here and refine it. I don't know that I would necessarily use this one, but each model that you use help you is going to generate it in a slightly different way. Let's say here, let's see, here's one of their canned ones. Yep. So there you go. So normally what we would do is we try this out and then start tweaking it. But it keeps you from having that writer's block to start with. That is often very very challenging. And that's it for my demo. Interested in any questions, or let me know what I skipped over by not switching tabs.
I think we caught you just in time, so you were good in that respect. So everybody, if you have any questions, now would be a great time to drop them in the chat. We do have a question already. It's from Robert. How much and what kind of compute would you recommend to run these AI apps? So what would you recommend be the basic profile of a machine to run this application locally?
Yeah, it's a good question. I try to use Llama 3.2 for a lot of the demonstration here. It is a much smaller, it's 3 billion parameter model. And with that, it will take, I think, 4 to 6 gigs of RAM. The websites will all have minimum requirements, but for Elastic, if you're going to run literally this whole stack on your computer, I would go with the Elastic build of that script, which is this one, because this runs.
Sorry, are you referring to start local, or because we
Yeah.
can't? Okay.
There.
Cool.
So use start local because it will only create one Elastic node in a versus a multi-node. So multi-node is going to require more RAM, and you get more capabilities, of course, with that. But if we're trying to think small, how small can you go? So that'll be a few gigs. Vectors are stored in RAM, so you need more RAM for that. So it kind of depends on your use case. Having a GPU is like the best thing. I'm running a M2 Max. The advantage there is that the Max, all the RAM is available to the model, but the Max CPUs are not as good as NVIDIA's. I also have a consumer 4080 or 4090 NVIDIA, and it's probably about 3 times as fast than my Mac in terms of tokens per second. But that runs about $1,000. You can get away with potentially something smaller. So you're going to need probably 16 to 32 gigs of RAM, and then a GPU comparable to the size of the model that you'll use. We generally are using our dev machines to create and test prompts and then we'll switch to Cloud Azure to run those inferences at scale. I've run Llama 3.3, which is a 70 billion parameter model on my Mac. It's slow, but it gets the job done. It could, recently I was doing something with vision models and comparing images and doing that, and turned out that Quinn 2.5, Quinn 2 Vision was the one that worked the best for it, but it wasn't going to be that would be what we were going to run the solution on, or even the analysis. But it allowed me to do a functional test, and then we, that model's not, in the Azure catalog. It's a little bit, and some of these others are a little bit harder to source. So, and then I had a colleague as well try to was doing something very similar, and that approach worked really well. So the minimum, you can go with even less, like Llama 3.2 has a 1 billion parameter, but your output will vary using in that Quinn vision example. I was comparing the differences between two scanned documents because we had labeled them as duplicates. So we wanted to know why they were duplicates. And I went with a 3 billion and I think a 7 billion parameter. The 3 billion one just made stuff up. It was like, oh yeah, this thing. And then the other one said because they had a document mark on the bottom right. So whoever marked it, that was the only thing that was different. So this was just, people took folders and scanned them in, and they were literal duplicates, but except for that. So that when so you can't, it'll work, but you're not going to get the right result. I mean, and that was, literally switching 3 to 7, rerun code, get the answer I expected. So that's the difference between 4 billion parameters. I guess.
Huge difference. We have another question from Toby. You mentioned an elastic wrapper that was recently released. I might have missed it, or it wasn't displayed at the time. Would it be possible to see that in action? Is he referring to like a wrapper that you used within your?
I've not used it here. I think it's here. It's here.
Okay. Can you make sure we see that on the screen?
So this is, I think, share screen. This is the wrapper I'm referring to. So this is just a Docker container, but let me switch this correctly here. So in Dify, you can use knowledge as you can use external knowledge. So if it implements the API, then Dify will use it in its context. And I'll do this again. I'll make sure I'll share it and share this tab. So if we come into here, here's the knowledge. And so you can upload your own, PDFs. It's going to chunk them. I can, for example, let me show you this. Find some. Just try to find something I can drop in here that's sanitized. Surprisingly difficult. Yeah, I think okay. I think I found one. So you could take this and put it here. So and then you have all these options to vectorize it, but that's what I'm saying. There are options, but they're not really configurable. If you come back here, we have the ability to register external knowledge, which uses that API. We've published a wrapper that'll do it for you, put it into a Docker container. And then when you are in your studio, which is what I would use, you can simply say, here, if it's registered, there's your knowledge. Come back in here and put it here. Now, in some cases, you have to explicitly add it, but in the agents example, you don't. So if I was in the here, simple workflow, and you'd have to put a knowledge retriever here. Yeah, and then put your knowledge in there. And then give it your query, something like that. So WYSIWYG, but so you can connect the plumbing really well. But what you'll find is that in general, you're going to want to store it in Elastic or something that's a little bit more scalable or tuned to your liking. So that's sorry, that was, I think, a moment where I was having tab sharing issues.
No worries. And I actually have a question. At what point of like a company's development workflow should they employ Dify? Should they start with this in the beginning? Should they start with this after they've kind of had some ideas of what they want to do? Where does this fit in with a company's journey into generative AI integration into their services?
I think it starts pretty early because it's so quick and flexible, and then you're going to grow yourself out of it. You're going to want explicit control because you'll eventually pick a model, and then you'll want to create your prompts specifically tuned for that model. Because, like, for example, a vision model interacts differently than a normal model. The prompts are slightly different. And so you'll start to gravitate. We're like, oh, we got a lot of custom code in this thing, and at that point, you'll kind of put it to rest. I think, at least that's how we've been using it. So we use Dify mostly for prototyping, quick POCs, and then we try to incorporate whatever we've built into the stack of the client, and not necessarily augment them. Although, now, if you don't have a stack, don't have those capabilities, it's pretty powerful because it's all inclusive. I mean, there's account management. Like I said, there's the monitoring and DevOps or SysOps side of things. You can look at logs. You can see if you run it. I mean, I don't know. I think I have to do something. I need an end block. And actually, I'll just switch to another one. I'll show you that you can back here and say, here for this one. So I come back here and I say preview, upload. Here's our Snapdragon. Tell me about Snapdragon. Again, I can see it kind of going through, doing its thing. I'm not sure what that's about, but what I want to show you is where is it? Here. You can see the trace of each step. So you can see, okay, well, that was pretty stupid. Then you realize, like, oh, actually, that's based on the text I gave it. What was the prompt, and how did that context get brought into the output? So here's the prompt that went into it.
That's a really great way to debug. That's really cool looking.
Like I said, it's now eventually I'll get frustrated with the constraints because you'll see some reference to someone doing the very specific and getting the results that you want, and and you'll need, and so then I'll just take this and export it. But we also we've incorporated this with LangChain, with Haystack, because ultimately this is going to produce an API here. So this is not really I'm wrong. So this is going to so it's going to expose itself to an API. So if you grow out of it, it's not like you have to ditch the whole thing. You can just incorporate it into whatever other whatever bigger piece that you're building, which is. And so we have a couple where it's kind of quasi, where we did a proof of concept, stuck with it, and then it's there are pieces there, but the Docker. Let me show you the Docker. It's like let me see here. Yeah, the dare I don't dare. There's 1, 2, 3, 4, 5, 6, 7, 8, 9 containers. So that's what I was saying. That it's sometimes a little bit cumbersome if you're going to deploy it,
right,
volumes and etc.
And we have one more question that just popped in from Cameron. This is a good one. What are the benefits of using Dify over some other tool like Langsmith?
As a I have kind of been burnt a little bit by the whole LangChain stack, so I always am a little hesitant to use it. Langsmith is, I think, is a good alternative. This one, what I've shown here is 100% open source. There's no there's really nothing that is not in the open source. If you wanted to go commercial, and if you wanted to have Dify host it, I think that's advantageous. The organization's very committed to it, so they're not making two products. It's been, you're going to get there's a release about every week or two. So you're going back in, you're doing a Docker pull, shutting down your containers, spinning them up, and nothing breaks. I think, but LangChain is also a very good choice as well. And if you have familiarity with that whole stack, then it's probably a good choice as well.
Cool. Yeah. Well, thank you very much for your time. Thank you, everybody who's watching out there, for spending, well, it's morning over here for me in the West Coast. But if you want to see a copy of these slides, we'll have those available and linked on the syndicated version of this video on our YouTube channel. Make sure to go to the Elastic community channel on YouTube and subscribe. And yeah, we'll also make sure that we have any pertinent repositories also listed there as well. So thank you very much, everybody, for watching. Michael, thank you very much for taking the time to show us.
Thank you.
Pretty amazing stuff.
Cool.
All right. Bye, everybody.